Hi guys, welcome to day 2 of quadratic word problems. On Monday, we focused a lot about using the vertex to solve these problems. Today, we're going to do something a little bit different, but very similar. So our first question, the formula for throwing a baseball in the air is represented by h equals negative 16t squared plus 12t plus 40, where h is the height of the ball and t is the time in seconds. So t is the time in seconds, so that gives us our x value. So our x value is our seconds, which means our height is our y value. So after how many seconds will the ball hit the ground? So we're looking for an x value. It's asking how many seconds, and we're looking for an x value when our y value, when the ball hits the ground. So if our ball hits the ground, that means that our height is actually 0. So the ball is not in the air anymore. It's on the ground. It has no height. It's at 0. So that should sound familiar. That should sound like an x-intercept. So when our y is 0, we have to find our x-intercept. And remember, when you're typing this into Desmos, you can't use any other value besides x or y. So we're going to change all of our t's to our x's. So we have negative 16x squared plus 12x plus 40. I'm going to zoom out so that we can find our graph. There it is. Zoom back in so we can see it. There we go. And if we're looking for when our height is 0, those are our x-intercepts. So our y equals 0 on here and on here. But if it's asking for how many seconds, I want you guys to actually think about this. How many seconds? Our first x value, or our first time, is negative 1.25. Can we have a time that is negative 1.25 seconds? No, that doesn't make any sense. So after how many seconds will the ball hit the ground, we have to go with our positive, which in this case is 2 seconds. Okay. All right, our next question. So the function negative 16t squared plus 1700 gives an object's height, h, in feet at t seconds. So again, our height is our y value, and our seconds is our x value. So when will the object be 1,000 feet off the ground? So when, that's asking for seconds, will the object be 1,000 feet above the ground? So it gives us a y value, but we have to find the x value that goes with that y value. So let's go over here to Desmos, and we're going to type in our equations. We have negative 16x squared plus 1,700. I'm going to zoom out so that we can see it. Whole thing. And there it is. So this is our whole graph. Okay. When will the object be 1,000 feet above the ground? So this is 1,000. And what you guys could do is you could do the same thing that we did on Monday where you click and drag, but it's going to be really hard to get that exact 1,000 value. I don't know, that's as close as I got. So the other thing that you can do, instead of coming over here and making a table like we did last time, we're going to make an equation for y equals 1,000, because if we know that our object is 1,000 feet above the ground, that means that our y is 1,000. So we're trying to find where our parabola hits this 1,000. Okay, so it makes that red line for us, which is really nice because it's easy to see. We have a black parabola and a red line. Super easy to see. So again, we have two values where y is 1,000. This one is negative, and this one is positive. Since we can't have a negative amount of time, we have to use the positive number. So about 6.61 seconds. However you guys want to round, that's fine, as long as you do it correctly. So about 6.6 seconds, the object will be 1,000 feet off the ground. Okay. Last question. So an object is launched 19.6 meters per second from a 58.8 meter tall platform. The equation for the object's height at times t seconds after the launch is s of t equals negative 4.9 t squared plus 19.6 t plus 58.8. All right, so we're going to come over here, we're going to type that in, and we'll talk about what we're trying to find. So negative 4.9 19.9. We can't use t, so we have to use x plus 19.6x plus 58.8. Come way down here and zoom in. So this is our graph. This is our parabola. And we're trying to find, the first question it asks, when does the object strike the ground? So we're looking for how many seconds for when, and then when it strikes the ground. So how high is our object when it strikes the ground? It's at 0. So this one's in meters, so it's at 0 meters. So we have to find where our y value is 0. So when our y value is 0, those are just our x-intercepts, because our y value is always 0. So when does the object, we're looking for seconds, we have a -2 and we have a 6. We cannot have a negative time, so we have to use the positive value, which in this case, 6 seconds. Okay. Now, how long does it take for the object to reach 75 meters? So this is the same as the last question when we wanted to find the object, how long will it take to be 1,000 feet above the ground? How long does it take for this one to be 75 meters above the ground? So we're going to come over here, and if it's 75 meters, that means that the height is 75 meters, which means our y value is 75. So we're going to go ahead and make a line at y equals 75, and it makes a nice green line for us. We're going to see where that intersects our parabola, which represents the path that the object takes. So y is 75 here, and y is 75 here. This one is okay that we have two values because none of them are negative. So we have a 1.167 and a 2.833. Those are both positive. So it's okay to have both of those numbers. So our first value, 1.167, that happens when our object is on its way up. Then it hits the maximum, and then it turns and it makes its way down. And it happens, or it gets to 75 meters again at 2.833 seconds. So in this case, 1.17 seconds and it's going up, and then 2.83 seconds and it's going down. You guys are going to be completing 3 very similar problems for your homework tonight. If you have any questions, please feel free to contact Ms. Zielinski or myself. Use Desmos for this. I promise you it'll be 10 times easier if you use Desmos than if you try to just do it by guessing or by using math. So use Desmos. It'll help you a lot. If you have any questions, please contact us. Thank you. Have a great day.